Redundantly setting up the network graph inevitably yields in contradictions. Their minimization, as well as assuring a network's quality, is the task of the block adjustment. This video explains the entire block adjustment ribbon. It contains 3 group boxes that will be briefly introduced at first and then in greater detail. Under the block adjustment group box, users can control which types of observation should be considered within a block adjustment and define a reference. Given the case that a block adjustment does not converge due to blunders, the eponymous group box contains a function to identify them. If the outcome of a block adjustment should be used to define a reference frame, then the Save Registration group box allows you to establish the basis for this task. On the left of the block adjustment group box, 4 types of observations can be ticked on or off. This is particularly helpful to identify the source of potential blunders. For instance, contaminated inclinometer readings due to ambient vibration within a factory. The project orientation tool can be used to create tailored coordinate systems based on information from the object space. For instance, the x-axis should run along a certain wall. On the top left, a coordinate system can be found that is used to illustrate how individual degrees of freedom, 3 rotations, and 3 translations were determined. Red items refer to an undetermined state, which means that the tool still requires information. Uniquely determined degrees of freedom are tinted in green. Referring scans to a coordinate system with just green components puts no geometric stress onto the scanning network. If an overdetermined scenario is given, the respective degrees of freedom are tinted in blue. Referring scans to a coordinate with some or entirely blue components creates stress onto the scanning network, which consequently changes their inner geometry. On the lower left of the dialog, the current axis of the coordinate system is displayed. The text box next to the corresponding axis can be used to specify offsets. Using this function allows to shift a coordinate plane, for instance, the XY plane, by a certain amount. In order to specify points on a coordinate plane, open a bitmap or the matchmaker and click on Detected Planes. Scantra will create points through which the coordinate plane will run. A tailored coordinate system can be defined by clicking at least 2 points for the first vertical plane and 1 each for the remaining ones, assuming that vertical axes are available. If no vertical axes are given, at least 3 points need to be defined for the horizontal plane. Note that the order in which the first 2 points were clicked determines the direction of the resulting x-axis. Should a station possess vertical axes, the rotations about the x and y-axis will be overdetermined and hence colored in blue. As soon as a sufficient amount of points has been defined, the traffic light man changes from red to green. After that, the icon can be clicked to start a block adjustment with the tailored coordinate system as a reference. Be aware that a solution should be favored where all parameters are uniquely defined, with the exception of rotations about the x and y axes in case that vertical axes are given. The reason for this can be explained by the associated weights. Given the case of a unique solution, where the degrees of freedom in the graphic are tinted in green, the created points will receive standard deviations of 0.1 millimeters. In an overdetermined scenario, the standard deviations will receive values of 1 centimeter in order to avoid deformations of the inner geometry of a given scanning network. The Tetris button on the right of the group box starts a block adjustment with a chosen reference system as listed in the reference system drop-down menus. This can either be a single station or a geodetic coordinate system in the case that the type of reference is set to station. Alternatively, a reference frame can be selected where the associated scans are not changing their orientation in the block adjustment. How the latter is defined can be found in the video about the permanent toolbar. If active stations are selected in the graphics window and a block adjustment is initiated, then only the selected and connected stations with respect to the reference station will be adjusted. Should no stations have been selected, then all active and connected stations are adjusted. A reference station can be set in the project tree and the graphics window by right-clicking on a station and selecting Set Station as Reference System, or by using the drop-down list in the center of the Block Adjustment group box. Navigating through the list can be done by using the mouse wheel or by entering the first letter or number of the desired station. Note that this menu only contains stations that are active in the project tree. The respective number of connected and unconnected stations are shown underneath the interactive stations labels. Clicking on Connected will select the corresponding stations. Connected with vertical axes refers to scans who possess sensor information about their vertical alignment during scanning, e.g., from an inclinometer or compensator. Not connected refers to stations that have no geometrical connections, neither by identical points or pairwise registrations, to the chosen reference station. Changing the reference station leads to an update of the depicted numbers and requires a few seconds. Once a block adjustment successfully converged, opens the inspector window, which by default contains the observations with the 10 largest normalized residuals. Note that the entries are sorted and chosen based on the normalized residuals, highlighted by the S0 values, and not the magnitude of the absolute residuals, which are represented by VT. Should a user want to change the behavior of the inspector window, then this can be achieved by changing the following 3 values in the inspector group box under the general ribbon of the settings. The maximum number of entries can be manipulated up to 99 entries. The filter Display V from determines the minimum magnitude of absolute residuals. The default setting is 1 mm. Note that contradictions that are provoked by vertical axes are not filtered by magnitude. The last filter, Display S0 from, determines the minimum magnitude of normalized residuals. It serves as an indicator for potential outliers. Per default, it is set to a value of 3.0. The inspector window contains 10 columns, namely, the On checkbox that can be used to deactivate an observation or identity. Scantra distinguishes several observation or identity types such as transformations, which are pairwise registrations, vertical axes, point identities among local points or between local and global points, coordinates. Note that once a coordinate has been switched off, all associated point identities will be deactivated. This process is helpful if a target has or was moved in between scans. Trajectories from kinematic laser scanning systems, cross-links that densify kinematic scanning networks. The columns from and to specify the direction of a relation, a trajectory, cross-link, or point identity between two stations. Should a point identity have been created between two stations, then the 2 corresponding point identifiers are added behind the from and to columns under point. The last 3 columns with the captions V, EV, and S0 signify the absolute residuals, the geodetic quality metrics, partial redundancies, and normalized residuals. Resting the mouse pointer over an entry in the inspector will show all directional components of a contradiction, which helps in identifying its cause. A video that exemplifies their use and interpretation can be found in the video on quality assurance of scanning networks. This button opens the protocol of the last successful block adjustment. More details about its content can be found in a separate video. If a block adjustment does not converge as a consequence of high contamination due to false pairwise registrations, then it is the blunder detection's time to shine. Instead of a numerically complex non-linear optimization that needs to be solved in the block adjustment, the blunder detection reduces the problem to a linear optimization, which always provides a solution. After the blunder detection has finished, a reduced version of the inspector window appears. It only considers the network described by pairwise registrations and hence does not feature the point columns nor the geodetic metrics. Instead, it shows the user the largest translational contradictions. The message window will print the largest loop closure error of the network, while the graphics will highlight the corresponding stations. Performing a block adjustment on the selection will, in most cases, reveal the pairwise registrations that provoked the divergence of the adjustment in the first place. If the user wants to freeze stations of a project with a reference frame so that they do not move during future block adjustments, this requires a previously successful block adjustment whose result has been saved. To save the result of a block adjustment, enter a name for the registration to be saved in the Name field in the Save Registration group box and then click on the button on the right.